what we are going to do, we will just take a very basic neural network example. We'll understand how PyTorch work, coding in PyTorch work, and we'll go code by code. You don't have to write any code. Everything will be available in the description box, all the notebooks and stuff. Just have to bear with me for some time, understand how things works in PyTorch, and start implementing. And if you're already implementing, you don't know the internals, just start understanding in a much a deeper way, so that you can explain stuffs and you can understand what you are doing, why you are doing. Okay, so to install PyTorch, it's basically any simple module installation in Python using pip install torch, and you are good to go. Okay, now first, once you have imported PyTorch, you just have to import it into your notebook or your code or your script to work. So we'll do the same, like import torch. Okay, so this pip install torch, and you can see it's already satisfied under my Colab notebook. And then import torch will just do the stuff. So it will actually import PyTorch for the session. Let me just omit this line and run again for you guys. And once that is done, let's just create. I've already set up some 4 to 10 lines of code. We'll just go through in this video very quickly. So create one tensor will be, you just call this torch module. So this is module, you're calling the module, right? And inside you are calling this tensor method basically. Okay, so it's a built-in method to create tensors, and you pass one array. You can pass list and all other stuffs, right? So let's just try that. Well, so let's say you have x as a list. Okay, where it is. Okay, I'm having 2 1 2 3, and it's already x. I'll just name it x1. Let's see if it works or not. And in the next, I'm just copying this one. Okay, and instead of this list, I'm just passing x1, and x1 is there in the runtime, so it will be available here as well. And you can see it is just printing one tensor, right? So your tensor got created. So here in this example, similar to any numpy array creation, you are just calling this tensor method. So in case of numpy, you call np.array. Here you call tensor torch.tensor. So very simple and straightforward, right? So your x got created. I'm just running this one for sake of simplicity. So your tensor got created. Now you can check the shape using x.shape. So I'm not going deeper into all these obvious methods. So it will be mostly similar to numpy or synonym to Pythonish kind of methods, right? So we are more interested in understanding rather than coding, because in the era of ChatGPT, code is you can definitely get how to work out stuff, but what to work out is much more important than how to work out, right? Okay, now you can see the shape. So it's nothing but a what it called list. It's called how many rows it has. It has only one row and it has 3 columns, right? So 1 cross 3, so it will be a vector basically, right? So in similar way, you can create a scalar. Here you can see torch.tensor, same method we're using, same function basically we're using, and we are passing one numerical value 2, and we're just trying to track the gradient of this tensor basically. So scalar is also a tensor with 0 dimension, right? So this is very understandable if you are from any finite element method. If you have gone through any finite element method classes, or you are from physics background, or you have a little understanding about vectors and all stuff. So yeah, scalar is nothing but a tensor with 0 dimensions. So once this w got created in the variable, so we can also check in the variable sections, right? W got created, it's a tensor, its shape, it does not have any shape, and the values here, right? So we can see all of this. So now next, simple computation. Let's just perform multiplication between x and w and store that tensor as y. And if you see, y is nothing but twice the value of x, so that this code is doing. And now you can use any kind of mathematical operation in this tensor. So from x and w we have created y, and now we are creating this loss from this y. So that's how the chain goes on, right? You have x, you have w, then x and w combines, it creates y. From y you are creating loss. Loss is nothing but one mathematical function call on top of y, which is y dot mean, right? So if you do that, 2 4 and 6 and in average will give you a 4, which will be again. Now if I try to print the shape of loss, so here your most code will stuck with the shape, okay, because mostly things you will do copy pasting from others code, right? And you will find it difficult. It internally it will throw some jackass error that you won't be able to solve, and will put that in ChatGPT and DeepSeek, and there also will fail to produce the where it went wrong. So mostly it will errors in this field mostly you will get is highly, the shape errors, where some internal function is returning some shape and it is expecting in another shape. That's where the error happens. So this thing you have to understand very well. Okay, so here also you can see when you are applying mean, so all this dimension of 1 cross 3 gives you a scalar, that means 1 cross 1, and you have a 4 as a value, right? Now let's do a back propagation, that means automatic differentiation based on chain rules. So any method, if you have difficulty, you can just scroll here. You can see it's what it's saying: computes the gradient of current tensor with respect to graph levels, graph leaves. Basically the graph is differentiated using a chain rule of mathematics, right? That means dy by dx equals to dy by dz times dz by dx, something like that. So yeah, that's it, and we're just printing the things that we have done here. So this is a very basic mathematical understanding how torch works in code practically. So yeah, if you have gone through it, you don't have to write it down. You just understand how things works, and that's it. Now let's just quickly, in the next set, what we're gonna do, we'll just create our first neural network here. And once the neural network is created, we'll just run one simple linear model and we'll just train basically the PyTorch model, and we'll just test it. Okay, a very basic ML pipeline. And here we are not doing any deployment and all those stuff, so those stuffs are coming later in this videos. Okay, I'm sorry for that. Okay, so important modules, we are requiring torch for doing all this kind of tensor related operations. For neural network, there is another module named torch.nn, and that stands for neural network. And okay, we are also importing the optimizers from tensor.optim module. Okay, so you can see by hovering over this, right, this optim is nothing but a package implementing various optimization algorithms. So we'll also deal or read with optimization algorithm neural network modules. Okay, now here we just wanted to simply implement one linear algebraic equation where y equals to mx plus c, where m equals to 2 and c equals to 1. So y equals to 2x plus c, and we want to make sure our linear PyTorch neural network understands that we want him or her to, no gender bias here, we want him or her to understand that we are trying to build one equation where y equals to 2x plus 1, and we'll give you unknown value of x, and we will be expecting the correct value of y in this model. And that's what we call the machine learning model here, right? So how we are initializing basically the tensor here, the input tensor, which we are calling torch.tensor, as we have just seen above, and we are passing one list of array, and array contains 1 2 3 4, and the target values here again for y 2x plus 1. So 1 will give you 3, 2 will give you 5, and so on. Okay, so that's your data part, your machine learning, your raw data, then data engineering, then all those data preparation, filtering, and factored data in a vector format. That's where you are here, right, in a real world problem. So everything is done in this two step in this video. How cool it is. Okay, now initialization of model. What we are going to build, we are going to build one linear model. So linear model, that's as we are using Python, right, we're not going to entirely create a neural network from scratch. That's the beauty of PyTorch. We're just importing the model that's already pre-built for us in PyTorch. So you're using, we have imported torch.nn module, right, which is our neural network, which is base for all neural network inside Torch, right? We're just calling that module. Okay, and we are using it using this super method. Okay, so we are calling super.init, so it will create the constructor for this neural network base class, which is base class for all neural network module. Okay, now what we are creating, we are calling this linear function basically. So it applies a linear transformation to the incoming data, where your incoming data is x and your output data is y. So it's nothing but y equals to mx plus c. It's a affine linear transformation. Okay, so how we are initializing it, as we have already inside this class, we have already initialized the constructor here. Now we are just calling self.linear. It's a variable that we are defining here, and we are just calling an nn.linear. So how we are able to use this nn.linear, because if you remember, we are passing this superclass basically, right? And once our variable is assigned, we are using this variable, and this variable is nothing but one transformation, right? We are just calling this transformation inside this forward method, and we are asking it to return self.linear, and this linear is taking the parameter argument as x. Okay, and x is nothing but our input data basically. Okay, so what it will give, it will give you the linear affine linear transformation to the incoming data based on the input. Okay, now we are just initializing the model. So how you are going to initializing the model, it's just you have to call the class, right? The class that we have created, this linear model, we're just calling it in and storing the values, blah blah stuffs inside this model instance. So now instance of class is created. Then another thing for machine learning, it's very critical, two things you have to define. One is the optimization. Okay, here you can see we are using this optim, right, from torch, and inside optim we are calling stochastic gradient descent. So these all stuffs we have already, you know, defined in neural network section very briefly, and in YouTube also you'll find easily all those stuffs. So this SGD is taking model.parameters as input, and learning rate, which is here fixed, we are passing 0.01, and the creation basically the mean square loss we are defining, which is nothing but we are calling the NN as a module, and MSE loss we are passing as mean squared error loss. So we are defining the model, the loss, and the optimizer. Now we are going to run the model or train the model basically. So we have defined here the epochs to be 100. Okay, that means how many times we want the iteration to be to be active, so that the model can learn y equals to 2x plus 1 that we have already defined there, right? So the first thing what it will do, it will give you a forward pass. That means the output, that means your expectation that you will be giving potatoes inside and you will be receiving gold outside. So this line, this predictions equals to model x, and that means your model is taking the input and it is producing the output. Basic neural network graph flow, right? That's your first line, or that's your first code. Now in the second step, what it is doing, it will now compute the loss. And how it will compute the loss, it will require the actual output, that is y, and the prediction value, and one function that will take both of this, and the function is your loss function, which is nothing but this. Okay, now you are defining your loss. Now in the third step, what you are doing, you are doing some gradient descent, right? So for optimizer dot zero grad here, now what this zero grad is doing, it resets the gradient of all the optimized torch tensor. Okay, so how it will reset, it will reset it to 0. Okay, so whatever old gradients are there, just reset it to 0, so that every time you will run, you will have a fresh run. Okay, now again, backward propagation, that computes your gradient. This dot backward method, we have already seen this one right here. So where, yeah, this back propagation, so automatic differentiation based on chain rule, that we have already seen. And once the back prop is also done, then we'll, based on the recommendation or output of the back prop, we are just updating the weight. And how we are updating the weights is optimizer, same thing, dot step. So these are the 5 main steps that goes inside any basic neural network. First, it do a forward pass, then computation of loss, then even if you eliminate this one, this resetting or setting the old gradient, you have one backward propagation, and then weight update. Okay, this is the basic algorithm, and with torch it's just 5 lines of code. Even it's a complex model, it will be like this only. And once that is done, it's some extra line of code that is printing basically your log collection, right, how your model is performing. So you can see after the first epoch, like the way it is predicting, okay, the prediction, it has a very high loss value, but from the epoch 10, the loss is reduced from 80 to 2, and then in subsequent step it decreases, it decreases, and here it is the least after 90 epochs, right? So now you can test using your test input. Let's say I'm passing one tensor as 5. So 5 is also there. No, 1 2 3 4 is there. So with 5 we're expecting 11, right? 11 will be expectation, and you can see the model is giving you 11.3. And in real world also, even it's a complex computer vision problem, NLP problem, or LLM, whatever, those are mostly these vector calculations only, but the data form is different. Let's say for image it's a array form of data, for NLP it's document data and all those stuffs. I mean, basically internally at the very core, these are the similar thing that you will be performing. So here you can see for prediction for x equals to 5 is 11.3. For this marginal thing, you can see it does a very great job. And the same thing, if you want to run instead of CPU, you want to run the whole thing in GPU, the only addition of code will be you first have to check whether it's your NVIDIA drivers are available. So if torch.CUDA is available, if this function gives you CUDA, then you use torch.devices, whatever it will give you, or else you use CPU, right? And you can print, like you can see this runtime, right? Runtime, I have to check, yeah, change runtime. So here you can see it's a CPU, so it is printing CPU. And if you change it to GPU, you can also run the same code in GPU. So that's the beauty of PyTorch, right? It's a modular, so there's no change of code you have to make no matter what device you are using. Here X is your input torch, Y is your output torch. This .2 device is the addition of code that you have to add so that it can move the tensors to GPU from CPU. Okay, so that's it for this video. In this video we have learned or understand basic tensor calculations. Then we have built one basic model class for linear model, and we have implemented one basic neural network model where the output, predicted output or expected output, y equals 2x plus 1, and we ran the model for 100 epochs, and we have seen that the model had done a very good job identifying the linear equation. And that's it for this video, guys. Hope to see you in the next video with more PyTorch videos. Thank you.